Hello students, in today's class, we are going to discuss the concept of moment of inertia. We have already seen the moment of inertia. What is moment of inertia? It is a property of a body. I repeat once again, moment of inertia is the property of a body by which it opposes the change in the state of rest or uniform circular motion. And this change in that property which is opposing the change in the state of rest or the change in the state of uniform circular motion, that property we are calling it as the moment of inertia. So let us see the moment of inertia of a rod. So what is the moment of inertia of a rod about different axes? So let us take the first axis as the axis which is passing through the center as well as it is perpendicular to the length of the rod. So here if you see first case one, it is what we are discussing. Now pay attention. This is a rod of length L. Try to understand, a rod is there of length L and mass M. So here I am writing mass M and length L. Just I'm writing the notation here. This length of the rod is M and the mass of the rod is M and the length is how much? L. Now what I'm doing, if I want to rotate this about an axis which is passing through the center, suppose this is the center for the rod, I want to rotate it like this. So what is the moment of inertia? That is, what is the opposition for this rotation? It is ml square by 12. The moment of inertia for the rod in this situation, it is ml square by 12. Now students, let us find the moment of inertia of the same rod about an axis which is passing through one end by applying or by the application of the what we have seen already, the parallel axis theorem as well as the perpendicular axis theorem. So let us see for that. The second one, I am calculating the moment of inertia for a rod about an axis which is perpendicular to the length of the rod, but it is not passing through the midpoint, it is passing through one end. It is something like the tangent to the rod. This the corner. So I'm rotating this rod about this axis like this. In the previous situation, I was rotating like this. Now I'm rotating this rod like this about this axis. So what I do, I apply or I take the help of parallel axis theorem. So what is this parallel axis theorem? Let us see. So here, if I take, this is the axis about the center and passing through the center as well as perpendicular to the length. So about this, we know it is Ig and it is, just now we have seen, ml square by 12. I want the moment of inertia about this axis. So you know, this is what already these two are parallel axis. What we consider again, the mass of the rod is M and the length is L. So if I consider the mass of the rod M and length L, what is the distance between these two axes? The distance between these two axes from here to here, it is L by 2. Now students, by the application or by using the parallel axis theorem, we can find the moment of inertia about this axis. So why I'm using only parallel? Why not perpendicular? You can see the two axes are parallel here. So I'm applying for the parallel axis theorem. So how to apply? Let us see. So if I want to calculate I calculate करना है तो कैसा करेंगे देखिए आप. I'm using parallel axis theorem. I is equals to Ig, that is moment of inertia passing through the center of mass or the center of gravity, plus m into d square. What is m? M is the mass of the object and d is the distance between the two axes. So if I want to go with this, so how to move Ig? Ig is what? This is I is equals to ml square by 12 plus this is m d square. D is nothing but L by 2. So that I am taking L by 2 square. So I is equals to ml square by 12 plus ml square by 4. Now we are having the two terms with addition. So let us add to get the final moment of inertia. So here I is equals to ml square by 12 plus, okay, we take the LCM here itself. So LCM is 12, I am taking LCM is 12. So this is ml square and this is 4. If you take here, that is 12 by 4, it is 3. So I'll take it as 3 ml square. Now I is equals to 4 ml square by 12. This is how much? We are having 3. So the moment of inertia about one end, it is ml square by 3. So this is the general expression what I have derived. That is the moment of inertia about an axis which is passing through one end of the rod and it is perpendicular to the length of the rod, right? So here, okay, this is the general expression. You may get or you may be asked for this general expression, or you may be like what I can say, इसी को बेटा mass or length of the rod they will mention as values. Mass is 1 kg, length is 2 meter. Find the moment of inertia about this situation. So just you can use this formula and you can find, just substitute and get the answer. This is another situation. This is the first one I have applied. This is the first passing through the center perpendicular to the length. Another is passing through one end and perpendicular to the length. Now students, they can ask you about an axis somewhat like this here in between also at a distance of L by 3. Just you take, instead of L by 2, you can take it as L by 3 also. Now I want to move with a standard question now. What is that standard question and how we can expect that? Let us see the third one. Suppose one rod is there. This is a rod. Try to understand. This is a rod of, again, mass M, length L. This rod, how how I am rotating, that is important. This is my axis of rotation. If I take, this is the axis of rotation, this is theta. Pay attention how the rod is. Like in the previous situation, first situation, we are rotating from the midpoint like this. You can see clearly I am rotating the rod like this. From the midpoint I am rotating. This is the first situation. The second situation is I am rotating from one end like this. I am rotating. Are you getting? Like this I am rotating. In the third situation, how I am rotating, this is the axis of rotation, so it is rotated like this. So what is the moment of inertia under this situation? This is supposed to be an important question. So how to find with this? Let us with. It's fine. So here, the basic definition of moment of inertia. What is the basic definition of moment of inertia? It is just the product of mass and the square of the distance from the axis of rotation. That is a perpendicular distance from the axis of rotation. So here I take that concept, or I can say that formula, to move or to derive the equation for the moment of inertia. Now take. Now देखिए बेटा, very important. This is, I take one element here. Try to understand. I'm taking just one element. Mass of this element, I'm considering it as dm, and the length of this I'm considering it as dx. Just imagine this is a length, it is having length dx, mass dm. Okay, and this length dx is at a distance, how much? It is at a distance of x from the axis of rotation. Now what is the definition for moment of inertia? अभी मैं बता चुका हूं. Moment of inertia is equals to mr square, जो हम formula use करते हैं. M is the mass, r is the perpendicular distance. mr square में जो है r, it is the perpendicular distance from the axis of rotation. तो देखिए बेटा, अब यहाँ पे हम कैसा निकालेंगे? So I want to calculate the perpendicular distance. Now I want to calculate the perpendicular distance. यहाँ से हम निकाल रहे हैं बेटा ये perpendicular distance. देखिए इस मास का perpendicular distance, you can see this one. This is the perpendicular distance, right? ये है बेटा perpendicular distance. यहाँ देखिए 90 degree बन रहा है. So this is the perpendicular distance. Now you can see if this is x, I can resolve this into two components, that is an theta. तो अगर ये x है, distance है, मैं just I am taking the help of resolution. But अगर आप triangle में देखते हैं, अगर ये hypotenuse x है, तो perpendicular क्या होगा बेटे? If it is x, then this will be x sin theta. X sin theta, and this will be x cos theta. So I need only this, that's why I'm taking x sin theta. Now the coming to the definition of moment of inertia. Moment of inertia only for this is mass, that is dm into perpendicular distance is x sin theta. Dm into x sin theta. Now let us move with this. So here, what is this dm? Dm is the mass of only this element. So I don't know this mass is how much. So let us express that dm in terms of the mass of the rod as well as the length of the rod. Let us see how to express. So for this, what I do, Here, suppose this is equation 1. I take now for the length L, complete length L, for the complete length L, mass is M. Unitary method I am applying. For complete length L, mass is M. So this dx length, dx is there. So how much is the mass? देखिए. For dx, how much is the mass? The dm. So let us calculate what is this dm. Dm is equals to unitary method dx by L into m. So therefore, this dm we can write m dx by L. So this dm, what we are doing, we are substituting this dm in this equation, that is dm x sin theta whole square में. ठीक है, अब इसमें सब्स्टिट्यूट करता हूं बेटा, देखिए अच्छे से what we are getting and how to proceed. I is equals to, this is dm, dm is m by L into dx, m by L into dx, this is dm, and here if you open this you are going to get x square sin square theta. Now this is the moment of inertia for only this part, only this part. इस part के लिए moment of inertia calculate कर रहा हूँ. So it is m by L sin square theta, and this is what, x square, and this is dx. Now students, this is the moment of inertia only for this part, but I want to calculate the moment of inertia for the entire rod, right? So here I start this length of the rod as 0, और यहाँ ये मतलब starting limit, lower limit is 0, upper limit यहाँ से लेके यहाँ तक कितना है बेटा, L है, तो lower limit is 0, upper limit क्या होने वाला है यहाँ तक जाने के लिए हमारे को L, तो lower limit 0 लेंगे, upper limit L लेंगे, और हम इसको integrate करेंगे to get the complete moment of inertia. So for this what I do, I is equals to m by L sin square theta integration x square dx 0 to L. I'm integrating. So this is the complete moment of inertia, or I say this is the total moment of inertia for this rod. IT is the total moment of inertia I'm writing. So this is I, this is the total moment of inertia, m by L sin square theta integration of x square. Integration of x square, it is x power 2. 2 means 2 plus 1 by 2 plus 1, that is x cube by 3. So therefore what I do here is, this is x cube by 3 and from 0 to L. Now this is total is equals to m by L sin square theta into, now students pay attention, this is what, upper limit minus lower limit. How to move with the upper limit here, L cube by 3 minus 0 cube by 3. So this is the moment of inertia, that is the total moment of inertia of the rod. It is m by L sin square theta, this is what, L cube by 3. 1 L get cancelled, square is there. So the total moment of inertia what I am getting here is m, this is L square by 3, and this is sin square theta. So this is the moment of inertia about this axis for this rod. Now a very important thing to note here, if suppose this is over, ml square by 3 sin square theta is the moment of inertia under this situation. I am showing you a special case for this. What is that special case? See students, if you clearly observe, it is ml square by 3 sin square theta, right? So if I take this rod exactly like this, इस तरह से मैं rod लेता हूं बेटा. Try to understand. I am taking this rod as like this, and I am rotating. So how much is the angle here? It is theta. Angle कितना बन रहा है? 90 degree it is becoming, right? So sin square 90, sin 90 is 1, 1 square it is 1, 1 into ml square by 3, it is ml square by 3. So when you make this rod exactly perpendicular, the moment of inertia, it is ml square by 3, and because sin theta is, sin 90 is 1, so therefore the total moment of inertia ml square by 3, which we have already seen under this situation, ml square by 3. So hope you have understood the different situations of moment of inertia about an rod.